Okay, so here is an interesting problem that we are given. We have a closed loop transfer function shown below, and we need to find the value of k for the settling time t of s equals 0.2 second, and the tolerance given is 1%. So first thing first, because this is already in closed loop transfer function, I am going to expand the denominator so that it looks more like the characteristic equation. So if you see here the denominator only, so 20s plus 20 times 0.5 will be so this is basically 10 s squared plus 100 k1 plus 2000 k2 of s. And you can see here, so I have s term here and another s term is over here. So let me put them together. 10s squared plus, so I can write 2000 k2 plus 20 and that is of s plus 100 k1. And remember that our characteristic equation is this. So the characteristic equation is s squared plus 2 zeta omega n of s plus omega n of s squared, right? So that means I am not supposed to have any number with the s term over here. So since I have 10, I need to get rid of that. So let me do that. So how do you get rid of that number 10 over there? So it's quite simple. Just divide the whole thing by 10. So we can say s squared plus 2000, 2000 k2 plus 20, and we need to divide this by 10, plus, so this is also 100 divided by 10 is going to be 10 k1. Okay, so this looks pretty interesting. So s squared plus 2000 divided by 10 is 1000. 2000 divided by 10 is not 1000, so this is 200 k2 plus 20 divided by 10 is 2, right? 2, and s plus 10 k1. And now that I have the equation looking more like the characteristic equation, I can compare them both and get my desired output. So that is, let's compare that with the 200 k2 plus 2 s plus 10 k1, as you can see here. So this term and these are, they are same, and also omega n squared is equal to this. So since I'm only interested in k2 because that's what the question is asking, I am going to focus on this. So 2 zeta omega n equals 200 k2 plus 2, and so zeta omega n equals, so divide 100 k2 plus 1. And so this is all I can do for now. But here, remember there is a tolerance of 1%. So recall that the tolerance, recall for 1% tolerance, what is my settling time? So there's a formula for that. So 1% tolerance, this is, we just need to memorize this, equals 5 over zeta omega n. If they give us 2%, so this is ts equals 4 over zeta omega n, and 3% are, so 5% settling time would be 3 over zeta omega n. And because they are giving us 1% tolerance here, we can simply use this formula in here. So that is equal to, so so step, so let me write this as a step. This is step 1. We need to convert this to the characteristic equation. This is step 2, and this is my step 3, right? So step 3, settling time equals, for 1% tolerance, I can say 5 over zeta omega n. So 5 divided by zeta omega n equals 0.2, which is given in the problem here. As you can see, t sub s equals 0.2. So that is equal to, so t sub s equal to, so let me just do this. So zeta omega n equals 5 divided by 0.2. So this is basically for 50 divided by 2 is going to be 25, right? So now that I have from step 2 and 3, I have the same expression for zeta omega n. So I can equate them, and in step 4, I can say 25 is equal to 100 k2 plus 1. So k2 equals 25 minus 1 over 100 is 24 divided by 100. Therefore, k2 equals 0.24. So this is my answer. So this is the value for k2 in the given characteristics in the given closed loop transfer function. So this is my second step. Let me just highlight them, and that is it. There you have it. So the value for the k2 here is 0.24.